An object roughly the size of the island of Manhattan has journeyed from another star system and is currently performing a series of maneuvers between Mars and the Sun that have left the global scientific community in a state of stunned disbelief. This object, officially designated 3I Atlas, is the third interstellar visitor we have ever confirmed, and its behavior is so anomalous, so utterly bizarre, that it challenges the very foundations of our understanding of the cosmos. It began by displaying what has been termed an anti-tail, a plume of material ejected towards the Sun, a feat that seemingly defies the known laws of physics. Now, as it hurtles towards its closest encounter with our star, it has transformed, growing a conventional tail, just like a comet. This sequence of events, this impossible transition from a forward-facing plume to a trailing tail, is what has led one of the most brilliant and controversial minds in astrophysics, Harvard's Avi Loeb, to posit a hypothesis as terrifying as it is exhilarating. We are not observing a rock. We are witnessing the deliberate controlled braking maneuver of an alien spacecraft. This isn't a fantasy. This is happening right now, in our own solar system, and the story of 3I Atlas is a rabbit hole of scientific anomalies, government secrets, and profound questions about our place in the universe. Are we on the verge of the single greatest discovery in human history, or are we simply witnessing a natural phenomenon so alien that our current science cannot yet comprehend it? Let's delve into the evidence together, and you can decide for yourself. The story of 3I Atlas is not playing out in the shadowy fringes of scientific speculation, fueled by grainy, ambiguous photographs. This is a real-time, high-definition global event. A vast and sophisticated network of the world's most powerful observatories has turned its collective gaze upon this cosmic enigma, tracking its every move, analyzing its every emission. From the Canary Islands, the Nordic Optical Telescope, perched high above the clouds, was one of the first to capture the breathtaking transition. Imagine the scene in the control room. Astronomers accustomed to the predictable waltz of celestial mechanics, watching in rapt attention as the inexplicable anti-tail of 3I Atlas faded only to be replaced by the familiar graceful arc of a cometary tail. This observation alone was enough to send shockwaves through the astronomical community. It was a direct, unambiguous recording of an object behaving in a way that nothing in our extensive catalog of cosmic objects ever has. Further south, in the crystal-clear skies of the Chilean Andes, the Gemini South Telescope, with its massive 8.1-meter mirror, has been providing the world with the most stunningly clear images of this interstellar traveler to date. These images allow scientists to not only see the tail, but to analyze its composition, its structure, and how it interacts with the solar wind, the constant stream of charged particles flowing from our Sun. Every photon of light captured by Gemini South is a piece of a puzzle that could redefine humanity's understanding of the universe. But the most tantalizing and frustrating piece of this puzzle lies not on a remote mountaintop, but locked away in a government database. As 3I Atlas made its journey through the inner solar system, its trajectory brought it remarkably close to Mars. By a stroke of cosmic serendipity, NASA's Mars Reconnaissance Orbiter was in a perfect position to capture images of the visitor. On board this orbiter is the High-Resolution Imaging Science Experiment, or HiRISE camera, one of the most powerful photographic instruments ever sent into space. HiRISE is capable of capturing images with such astonishing detail that it can resolve features on the Martian surface as small as a dinner table. As 3I Atlas passed by, HiRISE was able to capture a series of images that represent, by an order of magnitude, the highest resolution photographs ever taken of an object from another star system. These images are the holy grail for the scientists studying 3I Atlas. They could potentially reveal the object's true shape. Is it a chaotic potato-shaped asteroid? Or does it possess a more regular, perhaps even manufactured structure? They could show surface features, craters, or even appendages. They could settle the debate between comet and craft once and for all. But in a twist of fate that feels ripped from the pages of a political thriller, a government shutdown has resulted in these paradigm-shifting images being locked away. The data has been downloaded, it exists on a server, but it is inaccessible. Scientists and the world are left in a state of agonizing suspense. We are staring at a locked box that may contain the answer to the question, are we alone? And we don't have the key. This bureaucratic paralysis adds an almost unbearable layer of tension to an already dramatic celestial event. The object's closest approach to the Sun, its perihelion, is not some distant future event. It is happening today, October 29th. At this very moment, 3I Atlas is being subjected to the most intense heat and gravitational stress of its entire journey through our solar system. The data from this encounter will be critical, but the high-rise images remain the missing piece, the crucial clue that could unlock the entire mystery. The suspense is palpable, a global vigil of scientists and stargazers waiting for a glimpse of what could be the most important discovery in all of human history. The behavior of 3I Atlas is not just a single anomaly. It is a cascade of scientific puzzles, a collection of "that's not possible" moments that have left astronomers scrambling for explanations. Each new piece of data deepens the mystery, pushing the boundaries of what we consider natural phenomena, and lending more and more credence to the seemingly outlandish hypothesis that this is no mere comet. Let's break down these anomalies one by one, for each is a thread in a tapestry of profound strangeness. First, there was the anti-tail, the initial observation that put 3I Atlas on the map. Imagine a boat moving through water. Its wake, its tail, trails behind it. This is the fundamental principle of how comets behave. As they approach the Sun, the solar radiation heats their icy surfaces, causing gas and dust to be released. This material is then pushed away from the Sun by the solar wind, forming a tail that always points away from our star, regardless of the comet's direction of travel. 3I Atlas defied this fundamental principle. For a significant period, it sported a plume of material that faced forward, pointing directly towards the Sun. In our current understanding of physics, this is akin to the boat's wake appearing in front of it. There is no known natural mechanism that can explain this. However, if you were piloting a spacecraft and wanted to slow down, to enter into a more stable orbit, or to prepare for a change in direction, you would fire your engines in the direction of your travel. This is a braking thrust. The anti-tail of 3I Atlas looked, for all intents and purposes, exactly like a braking thrust. As if that weren't strange enough, spectroscopic analysis of this forward-facing plume revealed another impossibility. The material being ejected contained a nickel alloy. This is not just any alloy. It is a specific composition that has never been found in nature, not in any meteorite, asteroid, or comet we have ever studied. It is, however, an alloy that is well known to us from human manufacturing processes, often used in high-stress, high-temperature applications. The presence of a manufactured alloy being ejected from an interstellar object is, to put it mildly, a stunning revelation. It is a piece of evidence so direct, so pointed, that it borders on the unbelievable. Then there is the matter of the water. As 3I Atlas journeyed towards the Sun, long before it reached the frost line, the distance from a star where it is cold enough for water ice to remain stable, it began spewing vast quantities of water vapor. We are talking about a rate of 40 kilograms per second. That's the equivalent of a large swimming pool being vaporized into space every single day. At its distance from the Sun at the time, this activity should have been impossible. The solar energy was simply not intense enough to cause water ice to sublimate, turn directly from a solid to a gas, at such a prodigious rate. This suggests an internal power source, a mechanism for heating the object from within, something that comets simply do not possess. Finally, when scientists were able to get a more complete picture of the object's overall composition, they found it to be overwhelmingly dominated by carbon dioxide. The ratio of carbon dioxide to water was measured at 8:1. This is vastly different from any comet originating in our own solar system, where water is typically the dominant volatile compound. This high concentration of carbon dioxide does explain why the object was active so far from the Sun. Carbon dioxide ice sublimates at much lower temperatures than water ice. But it also marks 3I Atlas as being fundamentally alien in its composition. It was born in a different environment, a different stellar nursery, with a different chemical makeup than anything we have ever encountered before. Each of these anomalies, taken in isolation, is a significant scientific puzzle. The anti-tail, the manufactured alloy, the impossible water vapor, the alien composition, any one of these would be the subject of intense study for years. But taken together, they paint a picture of an object that seems to defy natural explanation at every turn. They create a compelling, circumstantial case that forces us to confront a possibility that is as awe-inspiring as it is unsettling. This brings us to the central debate, the question that is being argued in university halls, observatories, and online forums across the globe. Are we looking at a comet or a craft? Is 3I Atlas a natural, albeit bizarre, celestial wanderer? Or is it a piece of technology, an artifact of an intelligence far beyond our own? This is not a simple question, and the answer will have profound implications for our future. On one side of this debate, we have the argument for a natural explanation. This position, held by the majority of the mainstream scientific community, posits that we are witnessing an ancient comet, perhaps 7 to 10 billion years old, that originated in a star system vastly different from our own. The argument is that this comet, having formed in a different chemical and physical environment, is reacting to our Sun's radiation in ways that our current understanding of physics cannot yet explain. The anti-tail could be the result of a pocket of highly volatile gases erupting from a spinning nucleus, creating a temporary, forward-facing jet. The nickel alloy could be a previously unknown, naturally occurring compound formed under conditions we have yet to witness. The early activity could be due to its unique, carbon dioxide-rich composition. This explanation requires us to accept that there are unknown physical processes at play, that our knowledge of comets, based solely on the ones from our own solar system, is incomplete. This is, in many ways, the more conservative and scientifically rigorous position. The principle of Occam's razor suggests that we should not invent extraordinary explanations when a simpler, albeit currently incomplete natural one might suffice. Science is littered with examples of phenomena that initially seemed inexplicable, but were eventually explained by an expansion of our existing knowledge. The natural explanation, while requiring us to admit the limits of our current understanding, does not require us to make the monumental leap of invoking alien intelligence. On the other side of the debate stands Avi Loeb and a growing number of scientists who argue that the artificial explanation, while extraordinary, actually fits the observed sequence of events more elegantly. Let's consider the sequence again. An object enters our solar system and displays a forward-facing plume, consistent with a braking thrust. This plume contains a manufactured alloy. Then, as it approaches the Sun, the forward plume ceases, and a traditional rear-facing tail forms. This is precisely the sequence of actions a spacecraft would take to slow down upon arrival in a new star system, and then reorient itself to use the solar wind for radiation shielding or some other purpose. The artificial hypothesis doesn't require us to invent new physics. It simply requires us to accept that another intelligence, capable of interstellar travel, exists. This explanation fits the observed data like a key in a lock. The braking maneuver, the manufactured materials, the internal heat source. It all aligns with the concept of a functioning piece of technology. The counterargument to this is, of course, that extraordinary claims require extraordinary evidence. And while the evidence for 3I Atlas is deeply strange, it is not yet definitive proof. The locked-away high-rise images could provide that proof, but until they are released, we are left with two competing narratives. One requires us to stretch the boundaries of our physics. The other requires us to stretch the boundaries of our imagination and our place in the cosmos. The choice between these two explanations is not just a scientific one, it is a philosophical one. It forces us to ask, what is the more incredible possibility? That there are forms of matter and physical laws that we have never dreamed of, or that we are not alone? The profound weirdness of 3I Atlas is amplified by the fact that it is not an isolated incident. It is the third in a series of interstellar visitors, each one more bizarre than the last, creating a pattern of strangeness that suggests our galaxy is a far more diverse and active place than we ever imagined. Before we can fully appreciate the significance of 3I Atlas, we must first understand the context set by its predecessors. The first confirmed interstellar visitor, which arrived in 2017, was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name proved to be prophetic. Oumuamua was, in every sense of the word, weird. It was a small, dark, reddish object, highly elongated, perhaps 10 times as long as it was wide, tumbling end over end through our solar system. Spectroscopic analysis showed it to be a solid object, with no dust or gas surrounding it, meaning it was not a comet. Yet, as it began to leave our solar system, astronomers detected a slight but unmistakable acceleration. It was pushing away from the Sun faster than gravity alone could explain. This non-gravitational acceleration is the great mystery of Oumuamua. With a comet, such acceleration is easily explained by the outgassing of volatile materials acting like a rocket engine. But Oumuamua had no visible outgassing, no tail, no coma of dust and gas. To explain this, some scientists proposed that it was composed of a material we had never seen before, like a solid hydrogen iceberg, that was outgassing in a way that was invisible to our telescopes. Avi Loeb, however, proposed a more radical idea, that Oumuamua's acceleration was caused by the pressure of solar radiation pushing against a very thin, very light object. In other words, he suggested it could be a solar sail, a piece of alien technology. The debate over Oumuamua still rages, but it opened the door to the possibility that not everything that passes through our solar system is a natural object. Then, in 2019, came the second visitor, 2I Borisov. For a brief moment, it seemed as though normalcy had been restored. Borisov behaved exactly as a comet should. It was a large object, surrounded by a visible coma of dust and gas, and it sported a long, beautiful tail that pointed away from the Sun. It followed a perfectly predictable trajectory, governed solely by the laws of gravity. In many ways, Borisov was a relief to the astronomical community. It was a textbook interstellar comet, a validation that our understanding of these objects was not completely wrong. It provided a sense of comfort, a brief return to the familiar. And now, we have 3I Atlas. If Oumuamua was the strange opening act, and Borisov was the deceptively normal intermission, then 3I Atlas is the shocking, mind-bending finale. It is not just a single anomaly like Oumuamua's acceleration. It is a collection of anomalies, a series of behaviors that seem to have been designed to defy easy explanation. The braking thrust, the manufactured alloy, the impossible water output, the alien composition. It takes the weirdness of Oumuamua and multiplies it tenfold. The sheer diversity among just these three visitors is staggering. We have a solid, accelerating object with no tail, a perfectly normal-looking comet, and now an object that seems to be actively maneuvering and is composed of materials we've never seen in nature. What does this tell us? It implies that our galaxy is filled with an incredible variety of cosmic wanderers. The things we have been studying in our own solar system are just one local sample, one particular flavor of what the universe has to offer. The discovery of these three objects in such a short span of time, now that we have the technology to look for them, suggests that our solar system is a veritable crossroads, with interstellar objects passing through constantly. We have only just begun to see the true variety of what is out there, and the pattern that is emerging is one of increasing strangeness, pushing us further and further from our comfortable, predictable models of the cosmos. The arrival of 3I Atlas has triggered a response that is unprecedented in the history of astronomy. The International Asteroid Warning Network, IAWN, a global consortium of observatories and space agencies, has officially added 3I Atlas to its target list. This is a significant development. The IAWN's primary mission is to detect and track near-Earth objects that could pose a potential impact threat to our planet. 3I Atlas poses no such threat. Its trajectory will not bring it anywhere near a collision course with Earth. The decision to mobilize this powerful international network was not made out of fear, but out of a recognition of the object's profound scientific importance. It has been designated as an unprecedented observing exercise, a global fire drill to see how quickly and effectively humanity can coordinate its resources to study a unique and unexpected celestial event. This mobilization underscores just how seriously the scientific community is taking this object. It is a tacit acknowledgement that we are dealing with something far beyond the ordinary. And what if that something turns out to be an artifact? The implications are almost too vast to fully comprehend. It would be the single most monumental discovery in human history, a moment that would forever divide our timeline into before and after. The confirmation that we are not alone in the universe would ripple through every aspect of human society, from science and religion to philosophy and art. First and foremost, it would confirm that interstellar travel is possible. The vast distances between stars, which have always seemed an insurmountable barrier, would be shown to be traversable. This would be a profound source of inspiration, a new frontier for human ambition. But it would also be a humbling realization of our own technological infancy. We are still struggling to send probes to the outer planets of our own solar system, while another intelligence has mastered the art of crossing the cosmic ocean. The discovery would force us to confront a series of profound and unsettling questions. Who sent this object? What is their intent? Is it a passive probe, simply gathering data, or is it something more? Is it a messenger, a warning, or perhaps even a derelict, a ghost ship lost in the interstellar void? We would be forced to re-evaluate our place in the universe, to transition from being the sole, self-proclaimed masters of our world to being the new kids on a very old cosmic block. The societal impact would be immense. Religions would be forced to reconcile their doctrines with the existence of another intelligence. Geopolitical tensions could either be exacerbated by a new, unknown threat, or they could be rendered meaningless in the face of such a profound, unifying discovery. Would humanity come together in a shared sense of wonder and awe, or would fear and suspicion drive us apart? The stakes of this discovery are nothing less than our understanding of ourselves and our future. 3I Atlas is more than just a scientific curiosity. It is a mirror being held up to humanity. How we react to this enigmatic visitor, whether it turns out to be a comet or a craft, will reveal a great deal about our own maturity as a species. Are we ready for the answers that are waiting for us in the dark? The coming days and weeks are the most critical period in this extraordinary saga. Today, October 29th, 3I Atlas is reaching perihelion, its closest and most stressful encounter with our Sun. It is at this point that the object will be subjected to the maximum gravitational forces and the most intense solar radiation of its journey. This is the moment of truth, the crucible in which the true nature of 3I Atlas may finally be revealed. After it swings around our star, and reappears from behind the solar glare in early November, a global network of telescopes will be waiting, ready to analyze the aftermath of this fiery encounter. Astronomers will be looking for several key changes. Will its tail have grown, changed in composition, or disappeared altogether? The behavior of the tail will provide crucial clues about the object as material properties and how it responds to extreme heat. More importantly, will the object have fragmented? A natural comet, especially one rich in volatile compounds like carbon dioxide, could be torn apart by the intense tidal forces and thermal stress of a close solar pass. If 3I Atlas breaks up into a shower of smaller pieces, it would be strong evidence for the natural explanation. But if it emerges from its solar encounter intact, its structure unchanged, it would suggest a robustness and integrity that is more characteristic of a solid, engineered object. But the most important observation, the one that could provide the smoking gun, will be its trajectory. After perihelion, astronomers will be able to measure its path with incredible precision. If its trajectory has changed in a way that cannot be explained by the combined gravitational forces of the Sun and the planets, and without any corresponding visible outgassing to explain the change, it would be the strongest evidence yet of non-natural propulsion. Any deviation from its predicted path, any sign that the object has adjusted its own course, would be a watershed moment, a piece of data that could change the world. And all the while, the world waits. We wait for this post-perihelion data, and we wait for the release of those vital Mars images, the pictures that could provide a clear, unambiguous look at this enigmatic visitor. We are living in a moment of profound suspense, on the cusp of a potential discovery that could reshape the future of our species. So, what can we take away from this incredible story as it unfolds? This is more than just an astronomical event. It is a powerful lesson in curiosity, open-mindedness, and the importance of questioning our assumptions. The story of 3I Atlas teaches us that the universe is far more strange, more wonderful, and more mysterious than we can possibly imagine. It reminds us that we should never lose our sense of awe, that we should always be willing to entertain extraordinary possibilities, because sometimes the universe delivers them. Whether 3I Atlas is a comet or a craft, its journey through our solar system has already expanded our horizons and forced us to ask the biggest questions of all. I want you to think about this. If you could ask the intelligence that sent this object a single question, what would it be? What do you hope we will discover in the coming weeks? Share your thoughts in the comments below, because this is a conversation that we should all be a part of. Please consider subscribing to the channel for more deep dives into the mysteries of our universe.